My name is Andrew Fleck. I'm the Director of Sales in Canada here for Senstar Corporation. My colleague Todd Brisbois, he will be managing the questions that are coming in, moderating the Q&A panel. I think one of the reasons why I'm really excited to talk to you about this topic today is I've been with the company about 6 years now, and throughout my journey in the company, my role has changed. And about 3 or 4 years ago, I transitioned into a role where I took on a national perspective. And for those of you that are familiar with Canada, on that note, you'll hear some funny accents, some A's. I do speak in meters, not feet, all of these other fun things. But Canada is a very, very large landmass. And when I made this job change, I was a single sales representative that had to go ahead and had to span the country coast to coast, meet our customers, engage our customers, and go ahead and provide them site designs. One of the things that was really exciting at the time is my boss, I was reporting to the Chief Operating Officer, and he highlighted to me that we had tools that we could use that were in front of us, that we could at least reach our customers and help them design some systems along the way. And today I'd like to show you some of the things that at Senstar we use, because when we look at some of the products that we bring to market, using tools where we can't always get to site is really advantageous. In a situation where we're dealing with a global pandemic and we're working from our home offices, again, using tools that help us get to site and reach the customer and move the business are fantastic. So today, that's why I want to talk to you about using Google Earth. So I'm just going to switch over to my Google Earth right now. And for those of you that aren't familiar with it, it's normally available right down here in your start panel. Inside here, my PC, it was loaded for me. If it's not, you just go ahead, open up a browser, look for Google Earth, and you can go ahead and you can download it. It's a free download. So today, I want to go ahead and I want to highlight a little bit of things that we use Google Earth for. So today we'll be looking at laying out our Flex Zone perimeter system, with as well looking at camera coverage and potentially some camera installations that may happen, recognizing that Symphony is becoming the center core of the Senstar ecosystem, and all of our perimeter products integrate into that. But as well, when we're not using a perimeter product, a traditional fence sensor, using analytics within the Symphony platform are another great way to establish site security. And what we want to say by that, by site security, is that we're looking at the exterior right now, not so much the interior. But there are some tools that we can look at for that as well. So the first step that we want to do is we want to identify an area that we want to secure. So right now, the area that we're going to look at securing right now is this area right here. But how we would go ahead and do that is we would just turn around and we would add our address normally. So what I'm adding is I'm adding the Senstar manufacturing headquarters in Carp, Ontario. We'll go ahead and we'll put the address in and we'll hit the search bar here. It's going to pull us back a bit just so that we can see where we are. Now, I do apologize if there is any lags. I'm going to try to move as slowly as possible, but recognizing we're all experiencing bandwidth issues at the moment, we will need to be a little bit understanding. Now, I'm familiar with this site, so I know for a fact by looking at it that this is Senstar Corporation. But what if I wasn't familiar with it? What are some tools I could use? So the great thing about Google Earth is there's many tools, and along the right side here we have many different tools. Right around here controls the direction of which we're looking at. So if I wanted to square something off a bit, I could just turn around and I could move it. If I want to control the mouse where I'm at as well, I can move this way. But down here, this is the guy that I want to talk about for how we go ahead and we verify a site. So I'm going to pull this guy right here, and we're going to try to give it a minute for it to load. As it loads down on the street, we actually get an actual street view. So by moving our cursor a little bit slower, and I do apologize, I'm trying to go as slow as possible to respect bandwidth, we can get here and we can have a look. I know that this is Senstar, and this sign right here would normally say Senstar. I'm just trying to limit the amount I move my cursor today. But what we're going to do is we're going to actually go ahead and we're going to secure site. So site is Senstar's sensor integrated test environment, and that's what this area is back here. So I'm going to take a little bit of a moment here just to kind of position this so it's a little bit easier for us all to view. I'm going to zoom in a bit on the site, and I'm just going to square it off so that I can go ahead and have it facing square so we have as little movement as possible on the screen. And again, I do apologize for the shifting right now, but we do need a little bit of stuff. So again, this is site. If I wanted to verify that I'm actually looking at site, again, I would go ahead and I would put my little man down. Person, actually, my person. And at the gate here, I can see all these different signs. And right here, we know for a fact that this is Senstar's integrated test environment. Now, one of the other fantastic aspects of using Google Earth is the ability at times to see the surroundings around us. One of the things that we look at when we're designing perimeter security, whether it be from a traditional sensor standpoint or using analytics in Symphony, some major things we have to keep in mind. Vegetation. How is vegetation encroaching on our fence line? How is it obstructing views? Do we have any gates in play? Are they mechanical or are they sliding? One of the things that we keep in mind why gates are so important is on a mechanical gate like this slide gate here, mounting cable directly to the fence is not an acceptable solution because our cable isn't designed to be rolled, peeled back each time. So we have other technologies, and we'll talk about briefly on one of those technologies today. So now that we've gone ahead and we have a look, we know this is site, we see that we have some gates. We're going to exit our street view up here just because it's a little bit easier today. And I do apologize, I'm going back to using the search button to bring us over and over again because using the roll ball right now is really causing a lot of lag for some partners. So again, I'm going to try to straighten this site up so that you have a nice clean view of it. And we're going to go ahead in here. So once we've gone ahead and we've determined what our site is, we want to go ahead and we want to measure our site. Now there's two different aspects to access the ruler function inside Google Earth. There's a hotkey right here on your toolbar, and if you can't locate that on your toolbar, inside tools here, there's also a ruler tab. Now let's look at the ruler, and I'm going to put this in the center of the screen for you so we can see a few different things. There's three different methods in how we can go ahead and we can design these lines. I like to go at it from a bit of a different approach. As well, for those of you that don't speak meters, we have feet, we have kilometer, we have inches, we have yards, we have however the customer or the terminology you use in your region is available is there for your customer. So to start things off, just to get a generic idea of what the perimeter is that we're looking at so we can begin to lay out equipment is, we're going to use the polygon aspect right here. And what we're going to do is we're just going to go ahead and we're just going to hit 4 simple corners right over here that are going to go ahead and give us as good of a box as we have. So, and it's telling us here that we have a perimeter of approximately 820 meters. Or if I went ahead for feet, for those of us that are south of the border, we have a perimeter of approximately 2,700 feet. Now, this is a really good thing to know. Some of the things that we can go ahead and we can do as well afterwards is we can go ahead, once we save here, we can come in here and we can give this a label like total perimeter 820 meters. As well, we have some other functions in here that I recommend people use. So we're going to use the color of the red line for the perimeter today, but right here now you're going to start to see a width function and an opacity function. And what these do is these allow you to highlight larger lines, make things more apparent so that when you do your drawing. This comes greatly into effect when we're looking at maybe adding some perimeter cameras and trying to measure out some different sites for, what is the PoE limitations? Am I going to be using fiber? What are my communication plans? So if I adjust the width of this line right here, we'll go up to 3 just so people can see the difference. And we'll see that it's become a little bit thicker. Now, once we've gone ahead and we understand that we have the total perimeter of it, we want to take into some considerations. One of the great things about looking at Google Earth, if I even remove this line for 1 second, so it doesn't go away, it stays right here in my temporary place, but I can shut it on and off. So using Google Earth, we can take a look at a few things. I know that I have a sliding gate right here. Some of the things we know about this site that we may not know about others is I know that I have a swinging gate right here at my site, and I have another swinging gate right over here. And these are big things that we want to keep into consideration. So we're going to go back, we're going to lay out our total perimeter of 820 meters. And now let's begin to look out at laying out some equipment. I'm going to zoom in just a little bit briefly here to get towards the gates, just so you guys can keep some things in mind here. Now, what I'm going to do right now is I'm going to go ahead, I'm going to go back to the ruler tab. And what I want right now is, believe it or not, I want a line. This is my communications building. This is my cabinet inside of site. We have our racks here, all of our internet connections, everything like that. And I want to go ahead and I want to mount my very first processor as close to my sliding gate as possible. One of the reasons why we want to keep in mind where we locate equipment is, again, for communication aspects, trenching, how limitly can we affect the critical infrastructure at site. I think, as everybody knows, equipment is not always the total driver in a project. It's labor, and especially looking at a traditional fence line sensor, civil cost can be great. So if I go ahead here and I draw a line from here to here, I know that I have 16 meters. Fantastic. I'm well within any form of communication that we could use. So in this situation, this is telling me that I would probably go ahead and I would use one of our Ethernet cards. One of the fantastic things at looking at FlexZone, our copper fence sensor system, is that it supports communication from all different aspects. We give you the ability to use Ethernet, 422, single or multi-mode fiber. All of the comm cards are the same price, but what we wanted to do is bring you a flexibility there. So now that I know I'm within that communication distance there, I'm going to actually clear that line because I don't need to have that. So now I have my perimeter in place. So the first thing I want to do is I want to now add a processor to start laying out the equipment. So I'm going to, again, I apologize for the movement here. I'm going to try to scale back there. And we're going to grab the pin here. Now, what I'd like to do is show you something unique about the pin setting. So all of these pins, from the purple one here up to this pin in the corner, are all traditional. Senstar has gone ahead and we've designed some simple pins that will show you how to add these as well. These are unique to us, and we'll make these available after the presentation. But what you would do is you would go down here into this Add Custom Icon field. I have a folder here called my Google Earth design icons, and then I would just select one and add them. I do apologize, you must add them one at a time. So if I go ahead and I hit camera 1 and I click open, clicked OK, it's going to add right down here. Now, we don't want to be dealing with camera 1 because we're getting ready to lay out our equipment. So the first thing that we want to do is we want to add our first FlexZone processor. And I'm going to call this FC1. I'm going to have to use a little bit of spacing because sometimes the text overlays over top of the equipment. And then I'm going to go ahead and I'm going to mount this processor right here. I'm going to show that I have it on this side of the gate. Now, some people are wondering, Andrew, why are you going on this side of the gate? And there's a couple different factors. So if I'm looking again at a product specific situation like FlexZone, I know what the capability is of the processor, and I know that I can support 600 meters of cable on one processor, but I have a site that's 800 meters. So I'm going to be going into 2 processors. What this does is this also provides me an opportunity now to give a cost savings measure to my customer, because if I go ahead and mount my processor beside the gate right here, I will be able to have the ability to secure the gate and end the system. It'll be a closed loop. And then I'll go ahead and after that, I'll avoid trenching the ground. So we'll show you how to do that. So now once we have our total perimeter in place, what we want to do is keep in mind some of the different limitations of the system. So this is where we want to go ahead and we want to add different line measures. So what I'm going to do is, I apologize for cheating here just because of the way it is, but I do know that this line right here is approximately 30 meters. So I'm going to now take a thinner line on the outside here. And what I'm going to be trying to do here is finding out exactly where I have 150 meters. So I know that if I'm approximately 111 meters right now, and I have 130 meters there, we encourage you to run your cable as far as the 150 meters exists, but we know that that's there. And what we would probably want to do now is go ahead, We'll eliminate this line because we don't need to keep it there. And we'll go ahead and we'll add a splice kit. So down here inside my custom icons, we've created this S. The reason why we've created an S with this matter and showing that we have communication going two ways is because one of the most unique things about the Senstar system is that power and communication happen across the one field with no additional infrastructure. Everything's happening on the one wire. And we've gone ahead and we've created a passive solution. This is a non-active component, and it just allows you to join your cable to continue going on. The one thing to keep in mind is that although a processor supports 600 meters of cable, it only supports 300 meters off the A side and 300 meters off the B side. So when I go ahead and I'm going to save this, this splice kit here, I'm going to now need to figure out where my next 150 meters is to go ahead and add another splice kit down there. So I have my splice kit right here. We know that that's going to be approximately where we are. We'll temporarily save this line here for us again, and we're going to go ahead and we're going to add another splice kit to lay that equipment out for us. We'll call this splice 2. So I'm going to go ahead, I'm going to save that splice. With this now, again, I'm going to remove the line measure. If you start to get confused because you have these different things here, you just right click, delete. It's no longer part of the running model that as you see in the corner down here of the components you have in the field. So one of the things we now know is that we are at 300 meters here. And what I now need to do is I now need to get 300 meters coming back over this way. So we've run 300 meters off that side. We have 300 meters this side. What I'm actually now going to do to cheat the system, rather than go ahead and figure out my next 150 meter splice, I'm actually going to go ahead from this component here, and I'm going to begin to draw a path. Because what I actually want to know is where the 300 meter mark is. And we'll go approximately here to be safe. And what we're going to do is we'll save this line just so we know where we are temporarily. Go back into this pin, and then I'm going to grab a processor again. I want to take this processor here. I'm going to name it Flex Zone 2. And we're going to place that out at that field right where we are here. Place that processor there for us. And we're going to go ahead and personally, I'm going to remove the path measure. Okay, I'm going to actually apologize and turn it back on. I didn't save that icon. Please accept my apologies. And we'll add this here. We're going to click save now. We have that. We're going to remove the line measure. So now I know exactly where my equipment's going to be laid out. Now, the one thing that we do have to keep in mind is I have 300 meters going this way and 300 meters going now this way. It would be interesting to know what our distance we have remaining through here. So again, we'll use our path function just so that we know what we have. And what we have in between here is 211 meters. The unfortunate side with that is that, maybe we'd be stuck in a 150 meter cable set, but what I'm actually going to do is I'm going to use our 200 meter cable set because we have 150 and 220 meter cable set. And the reason why I want to do this is because as many continual runs as we have possible, that's the direction we want to go. But the difference though with this line right here, and we're going to keep this one in place, and that's because I want to show you something. What we're going to actually be doing for this line here is because this is now going to become the end of the system. And what I want to do to save you some infrastructure costs is I want to end the line. I want to turn around, I want to add a terminator into place here. A terminator is a way that we stop our system, and we can only go ahead and we can do this usually once, if not twice, because if we do, we turn around and we lose a closed loop configuration. This will not be a closed loop configuration either, but two splices mean I now have to start to a joint system. So there's your terminator. Now I do apologize, it's going to get a little bit busy coming on here around this gate because a lot is going to happen at this gate here. I'm just going to go ahead, I'm going to take my path measure one more time. I'm going to get myself 150 meters out somewhere, approximately right around here. And what we're going to do here is we're going to just temporarily hold that line again, add another terminator in place for us. Sorry, not a terminator, I apologize, I want a splice kit. Add a splice kit into place here. We're going to mark this here. We'll call this splice 3. And we'll go ahead and we'll save this and we'll remove this path measure here. Again, I'm going to open up this path measure right here, and I'm going to go into the properties. And what I'm going to do is I'm actually going to change the color just to yellow so that you guys understand that what we're doing here is we're measuring a unique sign. Instead of calling this path measure, what I'm going to call this is I'm going to call this a 220 meter run. One of the reasons why we want to add notes around here is so that we can keep in mind in some of the things. These paths I don't need anymore, so again, if I chose to, I could delete them so that I have simplicity in front of me. And what we have right now, believe it or not, is we have a secure perimeter. What we haven't done is we haven't added in a communication card to get everything to talk back over into our main hub. But before we do that, I want to turn around and I want to address this sliding gate. So we talked about we had a swinging gate over here and a swinging gate over here. And believe it or not, those have limited impact on our site design. And that's because we mount the cable directly on the gate. Where we have the most trouble is when we have a mechanical gate. I don't want to trench this open, but right now though, I have a complete functioning system. I've only ended the line here. When I add my communication card right now, I'm going to take this communication card, I'm going to put in my very first processor, and I'm going to use an Ethernet communication card. I'm a big fan of Ethernet when I can, so we'll put an Ethernet COM card here. And now what everything's going to be doing with this Ethernet is it's going to go ahead and it's going to pull everything back into our network manager service that we have running in here, or a Symphony server, better yet. Now, the last thing we need to do is we need to secure this gate. And this is what makes Senstar a little bit more unique compared to other people. Most people would be looking at a passive infrared detector, a beam, or microwaves. Ours are called ultrawave. They have a very specific point to be used, but I'm not a big fan of them in these types of commercial applications because we have this wonderful thing called a wireless gate sensor. And the wireless gate sensor really changed things for Senstar a few years back. It brought us a uniqueness that the market was looking for, where they could go ahead and they can reduce infrastructure at the field. So we're going to go ahead and we're just going to call this WGS. Now, as you can imagine, this is becoming a little cluttered at the gate, and that's going to happen in all situations with most things because this is our point of communication. We're trying to mount the wireless gate sensor as close to the processor because it is a true line of sight device. At the end of the day, when we stop and we look at this, this is literally a laid out perimeter that we can go ahead and we could bring to customers. I could remove this 220 meter line so that they don't know it and we could explain that. But now what I do though is I know that I have everything for my bill of materials. I need 2 processors. I need 1, 2, 3 splice kits. I need 1 terminator. I need a COM card and I need a wireless gate sensor. Everything we need to do is build a bill of material right here, and that's actually fantastic. This is one of the reasons that when you contact our sales team, we're always looking at, can you at least provide us a drawing? We know that you cannot turn around and sometimes share sites with us. Sometimes we have classified sites, but Google Earth though does provide us an ability where we can begin a discussion with you to help coach you along during those initial sales calls, or help you close throughout the journey as well, recognizing that we cannot always be on site with you, but we do have the technologies that are here. Now, if I'm looking at just a copper flex zone system, I would say essentially I'm done. But most of the things that come up now is what are our camera coverages going to look like? What are my zones going to look like? Historically in Senstar, we try to run cable lengths that are aspects of a zone, and then we would do what we call the crisscross effect for adding cameras. And as you can see here, I have a few different camera angles in place. I got to figure out kind of the right ones to go each way. So maybe I'll grab this guy right now over here, and we'll start kind of over by splice 3. And we're going to go ahead and we're going to mount this camera here, and he's going to look down that way. We'll maybe go over to splice 2 now and add a couple more cameras. We'll have one going this, maybe going probably not that way. I'd probably go this way. And then we'll add one more here. Go ahead, look for one, look in the other direction, add it here, and we'll add that there. And then we just continue to go around the perimeter, whatnot. We have designed different camera locations to go ahead and do that. So if we go ahead and we just add these, I'll delete the terms untitled place marks so you can see them, but you can name these camera 1, camera, whatever. And these are things that we want to keep in mind. Again, using your path functions, wondering what it's like if I came across from the cabin here to there. Am I within potentially PoE limitations? Hey, 75 meters, not so bad. I could use internet here. I could use Ethernet. What about if I decide that I want to try to home run from here all the way over to this camera without trenching? I'm now looking at 287 meters. Do I have a switch along the way? Am I going to need to run fiber? Am I maybe better yet to come along my fence line so that I don't have other trenching needs or anything like that? But the message that we're trying to show you here is that by using Google Earth, we can go ahead and we can turn around and we can help you lay out some different technologies to look at a site perimeter. It's just a few little coaching guides because right now we don't have the ability to get to site. Will this be perfect? No. But what this will do is this will begin an opportunity where we can begin conversations and relate to our customers. Personally, I'm finding one of the hardest things to do right now is that we're going ahead and customers aren't available, customers can't get to sites, projects are coming to a standstill. But one of the things we can do is we can look at what's going to happen when spring and summer come, where we're looking at potentially the ability to get back out to site. In my world in perimeter, this is generically a slow time of year north of the border due to the weather restrictions. But it's a great time that I can spend time with customers looking at future sites. Now, this is a little bit more of an easy site, but it's a multi-processor site. What I want to do is just maybe look over and give anybody who has a question right now of something that maybe we're not doing the way they would, or if they have a question, I'm going to ask Todd to have a quick look over at the moderator questions. And maybe we could take 1 or 2 questions here before I go on to one more simpler site for us, just a single processor solution. So I'm just going to go on mute for a minute or 2, and we'll see if any questions come in. Todd is communicating with me in the background, and I'll be able to get to 1 or 2 questions here, and I'll clean up the drawing.
Well, one of the common questions that came up are whether this recording would be available, and once the recording has been converted with this tool, it will be sent out. So you'll probably see something later today or tomorrow. So you'll be able to download that link and get access to it. I know it's been problematic for some who have had buffering issues, and hopefully you'll be able to get the recording and clean all that up and catch up with whatever Andrew has said that you've kind of missed out on. Also, Andrew, there's a question here. How accurate are Google Earth coordinates? For general length of cabling or other perimeter length, it looks fantastic. I believe the coordinates for Google Earth are probably within the GPS range, which is, I think, I don't know, sub 20 or 30 feet. Probably even a lot better than that, but I'm not 100% sure. I'm not sure if Andrew has any extra info on that.
Been that Google Earth is accurate within about, believe it or not, 1%. It is that accurate. Where we see discrepancies is human error. So I'm going to zoom in for just a moment here, just so I can show you something as an example. When I drew the polygon, I actually have my line slightly inside my perimeter line. That's where sometimes we have a discrepancy, so we may be off a bit. However, as you go down, you also see that I'm outside the perimeter line here. So we're very, very close, we're accurate. Now, one of the things that we do at Senstar when we design any system is we always add 20% cable overages, and that's for a couple factors. Number one, we would go through more cable at the gates, and that would be at the corners, sorry, and that would be the same if we were actually running Ethernet. If we were in conduit, we were trenched underground. Every time we bend, we lose a bit. Again, with gates, we have to go up them and then underneath them, and that's the same with a pedestrian gate. And luckily here, we managed to save the meters that we would have used here by using a terminator, but we see that we need that. So if we had an 800 meter measurement here right now, believe it or not, the Canadian sales team would actually design you a quote that would probably have 960 meters of cable. We'd probably peel it back a bit actually to 900 because we have a beautiful 600 meter kit and 300 meter kit. And I'm comfortable with that variance more to 15%, and great things can happen that way. So from that standpoint, I feel it's very accurate, and that working with us or yourselves, we do add in a little bit of a buffer. Now, one last thing that I do want to touch on is if we do not have an ability for a software integration, one of the unique things that Senstar has is we also have additional tools to bring in dry contacts, i.e. an output card. So I have an option that if it's just 4 cameras, I could drop one right on a processor, and that's 8 cameras or less because we have 4 IOs on board. But one of the things we do have is we have an Ultralink, and we drop these inside our network cabinets. It provides you 8 in or 8 out. And then what we find is we had a 32 output expansion card, and that's how we bring a lot of cameras into place back into the control room. So right now, if I was actually doing this site, I would be doing 2, 4, 6, 8, 10, 12, and I might even add a 13th and a 14th here or a 15th in the middle, depending on what it is, meaning I would need 15 outputs. So we would go ahead and we would look at using that Ultralink. Again, when we have a bit of a cleaner view, I'm trying to use things a little larger right now so people can see them, but there is a way we do this a little bit cleaner so that it doesn't always look so bad here. But now what I'd like to do is looking at site here, which is a very simple site to do. It's actually really beautiful. For any of you that's ever heard any of our presentations, or especially one by me, I open this up right away. This is a live test bed, so this is your Ultralink test bed. This is a 12 plus 2 foot topper for a 14 foot correctional fence. This is a double layered Sally port. There are light ballasts across here. There's our decorative fence. There's mag bar. We also have many different fence types from around the world. So you'll probably notice as well too, I don't know if it shows up as well if I come in slowly, but these are actually welded mesh fences here. These are chain links. We have some Ameristar over here as well, and that's actually the rail for the robot that we tried to bring to market a few years ago. So our test environment is a very exciting place to look at. Now what I want to do is I want to take you over to a customer of ours that we used before. And I'm just going to pull off this temporary place right here, just so we don't see it. I want to go over to AIM Marina.
I got a question, Andrew.
Sure.
If the fiber is connected on both sides of the processor, why do I need a terminator?
So this is when we're looking at fiber versus our copper flex zone solution. So right now we were discussing a copper solution where sometimes we end the line to avoid trenching. In fiber, we occasionally see this as well too. Now we do our best to close things back into the equipment room, but keep in mind that even all fiber systems have either a dual start end module, and that's when you're closing in the rack, or you could have a start and an end module that are separated, meaning I may be ending my module not directly back to my unit. So it comes down to which system we're looking at. Today I'm looking at more of our introductory system, which is our flex zone. It's available in a kit solution, 4-zone, designed for distribution for commercial aspects. opening up an avenue that people may not be thinking about for security. And especially at a time where we're looking at pandemics and potentially an increase in crime, this is a great place to go to your substations, your self-storage yards, your boat marinas. These are the places that are going to see crime, immediate crime. Where can copper be stolen? Where can gas be stolen? Where can motors be taken off of boats? And this is where we need to think about, and this is kind of where we wanted to go ahead and introduce clients today. A lot of our higher end customers provide us the ability to work off of the drawing. So if you're looking at a government account, you're looking at maybe a high-end electrical utility, looking at a 12 or an 18-month planning cycle, you're going to see some drawings. But one of the things we also like to do is we like to take these drawings and compare them against the Google Earth, because we sometimes see things that a CAD drawing doesn't show. And that's one of the reasons why I'd really like to come into AIM Marine right here. So I apologize, I'm coming in a little bit quicker than maybe some people's bandwidths kind of support, and I do apologize for that. I'm just going to kind of straighten this out a bit so I can look at AIM. Now, if you look at AIM Marine here, Todd and I went down this site about 2 years ago. They were right down the way. It was a neighbor that was experiencing a lot of crime. Believe it or not, our COO was getting a lot of service done on his boat there. It was a little bit personal to us, and we like to help our neighbors. So we decided that what we'd like to do is pilot the LM100 solution and the FlexZone solution to see how they respond. For those of you that are not familiar with the LM100, it's probably, in my biased opinion, one of the most innovative products on the market, as it's an intelligent light which allows you to provide an actual perimeter intrusion detection system. However, all of us as security professionals, we know that the #1 thing that we're taught: increase your lighting. Lighting is a #1 deterrent. Obviously, cameras are a second, and then a perimeter sensor is a third. But deterrence is what we're looking at. Now, looking at AIM Marine right here, some of the things that we noticed when we went into this site. As you can see here, all this green shrubbery back here was an absolute nightmare when we came in. In fact, this whole side here looked as bad as this, and we had to have the customer. Luckily, it was slow season, so he had his staff and he whacked it all out. But what's great about this is we have a simple site. We have a single processor site. So if I go back into my ruler and get my polygon, I'm going to go 1, 2, 3, 4, 5. And we have our site, 228 meters. I think we actually measured them out at 250 or that when we did it before. So what was really great though is we came in, and I'm going to go down to Street View actually to show you guys something that really made this exciting. And this is where we were able to have some help when we were figuring out how to do it. So when we went down to the site, we didn't know how we were going to help things out and where we were going to get the equipment until we found out that this site was powered, this sign right here. And what that did is that gave us the ability to come in and tap off that. And if you actually look, it's hidden by this Crestliner sign. Our processor is sitting right here. What we're looking at here is, believe it or not, the LM100 technology. So you can see the light on the fence, and the FlexZone system is going ahead and it's running across there. What made this site a little bit more difficult was that we had 2 mechanical gates and we had to trench. We weren't able to terminate and keep things at a cost-effective nature. However, luckily, based on the type of consumer this was, he had equipment and he kindly got some trenches for us to continue the loop. Now, the greatest part about this whole site here is everything we needed was right at our disposal. We had our equipment room in here. We came right out there. We mounted a processor, and then we started laying out our lights one by one by one. Now, I do have a light luminaire, and I'd encourage you not to do this just because the spacing on the lights is every 6 meters, and it doesn't look very good. So if I add this one, and then I go add another one again, probably not the greatest idea. However, what's very important is to maybe identify one that becomes your access point, because that's your communication back. And then afterwards, you just mount them around the system similar to a fence sensor. So what we're trying to show you here is this one with simple IO contacts directly back. We use the auxiliary card on the main gateway. So if I was to go ahead, I'd add an auxiliary card here compared to an Ultralink processor, and they pulled their alarms back into there. One of the things we had to help him out with was understanding his camera locations and what his runs were in his fields of view, and we were able to lay some of that stuff out for him. Now, the only message I'm really trying to send across to you guys today is that in this time of quarantine, and we're losing the ability to see customers or to forward think our plans or anything of that effect, we do still have tools before us. This morning, I'm having the ability of using not fancy software. Sure, things could be better, they could be sexier, they could be more engaging, but what we do have is we have a tool to sit before you to decide either a perimeter fence sensor, to look at what our infrastructure is for our camera systems, to maybe look at what our fields of view are if we're using field of view calculators. The whole message here today is that I am not a technical expert. I have a bachelor's of business. I'm a businessman, and I'm able to use these tools in front of me to bring a technical design and to bring a sense of ownership and understanding to my customer. And I think that in this time of having less ability to communicate, less ability to bring knowledge to our customers, the more visuals we can do, the more we can add these go-to webinars, maybe lay out a site with our customer, educate them on some of the things that we're looking for. These are all tools that we can do to strengthen our relationship and strengthen our designs that we're bringing to market in this time that security is a lull. Because I personally believe that in 4 to 6 weeks, potentially sooner, we are going to be busier than ever. And I do not believe we are going to be focusing so much on the interiors of the facility, but the exteriors. We will be looking for traditional fence line sensors to protect property. We'll be looking at increasing camera coverage. We'll be looking at the use of analytics. But one of the things that we won't have access to do as we prepare for this is to site, to go on a site walk, to measure. And let's be honest, maybe 20% of the solutions that we have out there come via drawing. Perimeter security is for everybody. Outdoor security is for everybody. It's about how can we simplify the message? How can we show that the tools we have before them, and what does this look like?